we will go over Excel project number 7 on confidence intervals for our Statistics OER course. Remember to click on the PDF description and either view it or download it, and also click on the Excel project file and download it to work on it in the Excel app or to upload it in Excel Online. Per the instructions here, we are asked to construct a 95% confidence interval. And for the mean number of hours slept for the population, assumed normal from which we took the data, let's see what the scenario is. You do a study of hypnotherapy to determine how effective it is in increasing the number of hours of sleep each night for adults 45 years old or older. You measure hours of sleep of 12 adults in that age range with the following results. And here you see the results. They are separated by a space, which is what Art of Stat wants, either separate by space or by commas. So you can actually just copy these from the PDF, and also it's available to you in the Excel file. So we will use the Excel file to perform the calculations and provide the necessary answers. So first, we will see how Art of Stat does it and take a screenshot. And then we will replicate all the work that Art of Stat does so that we can have that coded in our Excel file. So for Art of Stat, we need to go to the Inference for a Population Mean app. So here you want to scroll down. This is the tab of the web apps, and you want to scroll down until you are in this app under confidence intervals and significance tests. The second app is Inference for a Mean, and you want to select that. And when you come into that app, it automatically has some data uploaded, so it has a default screen. But our project says to choose under Enter Data your own, and under Name of Variable to write the sleep time. The units for the sleep time is hours of sleep. So up here in the scenario, it told us that these values that we see here are hours of sleep. So here I'm going to say enter data your own. Then I'm going to write here sleep time in hours. And then I have to enter the observations. And here it says enter or copy and paste numbers into the observation box below, separated by spaces or commas. So your project description gives you the data separated by the spaces, but also the Excel file in cell A16 over here gives you these numbers separated by spaces as well. So I'm going to copy them from here and I'm going to paste them in the observations box. And now I want to make sure that I create the correct interval. So the project says make sure the type of inference is the confidence interval and the confidence level is 95%. Make sure interval is selected for the choices between interval, lower or upper bound. So by default, it goes under confidence interval, and then the bounds are two-sided, so you want to stay here under two-sided, and you want the confidence level percent to be 95%, which is the default. Also, I recommend that we show the t-score. I also see that in this version of Art of Stat, we don't have here at this table the degrees of freedom to the right, which actually we had originally. So this Excel project is asking you in columns G, H, I, J to replicate the tables in ArtofStat. And the first table in ArtofStat doesn't give us the option to show the degrees of freedom in this version. And the t-score is included in the next group. So it will be nice to have the t-score showing here. And then there is 4 entries in the third table. So here we are missing the degrees of freedom, which I cannot find in the input pane on the left. So our next job is to take a screenshot. When you take a screenshot, remember to include the title of the app you use, anything inputted by you and produced as an output by the software. So this looks pretty good. We need to paste it in L2. L2 is in this location over here that I just highlighted in yellow. So I'm gonna paste it here, and then I want to resize. So let me make it small enough to fit the table, and here it is. This is my screenshot. So the rest of the project is gonna ask us to actually duplicate this project, all right? This screen basically. So we will have somebody enter the inputs, and then we will just create the interval for them using the formulas that are coded already in ArtofStat, but we will code them in our Excel project. So let's see what it says after this. It says in E2, E3, E4, and E5, use the count function, use the average function, and use the standard deviation of the sample to find these statistical measures for the sample data. And also in E5, enter the confidence level in % form. So sample size in E2 equals count of, highlight all the values they gave us, is a size 12. The mean equals average of the data, and the standard deviation equals stdev. We want the .s for the sample. This is a sample of only 12 entries, and we want to close that. And the confidence level is 95%. For Excel, we will need to include the % symbol there. So 95% is the confidence level. So this is the information that we originally give to ArtofStat, and then ArtofStat does some calculations behind the scenes based only on these entries that we gave it. So the first one is in E7 and in 8. We want to use the confidence level to calculate alpha. Alpha is the complement, so 1 minus the confidence level. So here I'm going to say alpha equals 1 minus the confidence level, and I'm just going to click on that cell. And then alpha halves will be half of alpha, so it will equal alpha divided by 2. And it is okay to leave it in decimal form. What is alpha halves? It says here in the project, this will be the area in each tail. So remember that if the middle 95% of the data is in the normal curve between two standard deviations within the mean, then each tail will be half of the 5% that is outside of that interval. So then it says, copy in G3, H3, and I3, copy the values of the sample size, the sample mean, and the standard deviation. Do not enter the value yourself. Copy the location, or tell Excel to go find it in that location. So the sample size will equal E2. The sample mean will equal E3. and the sample standard deviation will equal E4. We are not going to calculate them again because we already found them. After that, we want to calculate the degrees of freedom. Degrees of freedom is equal to n minus 1 using location G3 for n. So going back to the Excel file, the degrees of freedom will equal, they want us to use G3 for n minus 1. And the degrees of freedom will be 11 since the sample size is 12. So next, in G7, copy the value of the point estimate for the population mean. No manual entries. So your estimation of the population mean is actually your sample mean. So what you want to do is you want to go to your project and you want the point estimate to equal the sample mean. And you can pick the sample mean either from H3 or from E3. Anywhere you want is fine. And pay attention here that these values also show up in ArtofStat, with the exception of the degrees of freedom that I wasn't able to find in the new version of ArtofStat. So I do see 8.983 as a point estimate. So what's the standard error? This value that is here calculated as 0.373. So our project says that we have to use the formula for the standard error of the sample means to calculate the value of the standard error. So use variable locations, the standard error equals S, the standard deviation of the sample, divided by the square root of n. So here I'm going to use a location for the standard deviation, and I have it either in E4 or I have it in I3 divided by SQRT, which is the function for the square root, and n is the sample size. So I'm going to use that location G3, and this will be 0.3725. That rounded is 0.373, like ArtofStat showed that. For the t-score, I have to find the t-score 2.201, hopefully. Let's see what the instructions say. We want to calculate t alpha halves using the inverse t two-tail function. It gives us the name of it, is t dot inverse dot two-tail, with probability equal to alpha and degrees of freedom found in location J3. And it says use variable locations, don't punch in the numbers yourself. So I'm going to go here and I'm going to say equals t dot inverse, and I have two options, returns the left tail inverse or returns a two-tail inverse. Confidence intervals are two-tail tests because we are looking for the central probability. What is your probability? The probability is the confidence level. So here it tells me that I want to use, the probability equal to alpha. So when it asks you for the probability, it has to equal to alpha, and then also provide the degrees of freedom that you found in cell J3. So let's go back into our project. Again, equals t dot inverse. I want the two-tail. All right, probability. I will just click on the cell that I calculated alpha, comma, and degrees of freedom, I will click on the cell that I calculated the degrees of freedom. And I will get this t-score that is 2.2009856, and that rounds to 2.201. And then the error bound for the mean, which is the margin of error. The instructions say to calculate the margin of error, EBM minus error bound for the mean, as not minus, sorry, the EBM or error bound for the mean, this is the same as margin of error as the T alpha halves that you found times S X bar. And Sx bar is the standard error, is the standard deviation of the sample means, the distribution of the sample means. So I'm going to calculate this error bound as equal to the t-score times the standard error that I found earlier. And if I have done a good job, it will be 81988,581. That rounds to what Art of Stat found for us, 0.820. So notice here that I skipped one item where you have to write in cell D4. Why does the T inverse 2T give us T alpha halves when the probability we entered is alpha? So here you have to write within words something that basically is along the lines of the T inverse dot 2T asks, because it's a two-tail, asks for the probability on both tails, but because the T distribution is symmetric, the probability on one tail, on each of the tails, is alpha halves. So it will give us the t-score, that critical value, that corresponds to an area in the tail, in one of the tails, equals to alpha halves. So that's what approximately you have to say there. And then for our final step, we want to type the symbol to do the last table in the Art of Stat page output. We want to type the symbol for the population parameter we are trying to estimate. So here, if you see, it says mean mu. So to do that, mean, in Excel, you can insert symbols. And when you insert a symbol, you want to look for the Greek letters. Let's see if we can find them. And there you can find the letter mu to insert, which I already did by double clicking, or you can select the insert. And then it says find the lower bound. So your lower bound is your point estimate, which is in cell G7 minus the margin of error. And the upper bound equals your point estimate, which is the center of your interval, plus the margin of error. And for your confidence level, you just want to copy the confidence level from here. And now you have recreated the table in Art of Stat. Of course, remember that a lot of times when I give you feedback on your assignments, I mention that it is not useful to have 10 significant digits in values. These are like sleep hours, so nobody really cares how many millionths of an hour you slept. And that's why Art of Stat rounds these values in some numbers that are more easily read and understood. So we will leave our data like this, but again, when you are presenting them to an audience, a general audience, you want these things round. So this is your interval. The lower bound, you see here, it's also graphed for you, is from 8.163 hours to 9.803 hours. And again, the last thing you have to do is to interpret the confidence interval using a complete sentence. So to use a complete sentence, your language has to be scripted. So in cell D21, you want to write something of the form, we are 95% confident that the true population mean of sleep hours for adults 45 years old or older is between 8.163 hours and 9.803 hours.